So here we're asked to solve the equation y times dy over dx equal to y plus x cubed plus 3x squared minus 2x. And so the first thing we want to do here is to rearrange this just a bit. And so we're going to divide through by x and subtract y from each side. And when we do this, we can see that it'll be rearranged to look like this. So this is how we'll present the equation moving through this that we're trying to solve. This is exactly the same as this. Again, just divided through by everything by x and brought y to the left-hand side of the equation. So why did we do this? Well, now we see that this equation is in the form of dy over dx plus y times some px, which our px in this case is a negative 1 over x, and this is equal to some function q of x, which is this x squared plus 3x minus 2. So it's important that we try to get it into this form because when we do, this is our definition of a first order, first degree linear differential equation. And so we have a set procedure of how to solve this, which involves the use of this integrating factor e to the integral px dx. So we're looking for this integrating factor e to the px dx. So we recall that our px, remember, was this minus 1 over x, whatever the argument here is, times the y. So in this case, it's a negative 1 over x dx. And so when we integrate that, we get a standard integral negative natural log of x. So now we can use that to substitute back into our definition of our integrating factor. So in this case, it's e to the minus natural log of x. And so these two functions undo each other, and the minus sign flips it. So it's going to be equal to 1 over x. So this is our integrating factor, 1 over x. So now we can use this integrating factor to apply it to the general solution for this type of equation. And we recall that when we do that, the general solution is going to be y times our integrating factor equal to qx, which, remember, that's the right-hand side of the equation, times our integrating factor, again, integrated with respect to x, plus some arbitrary constant c. So if we plug in those values here, you'll see we have our y times 1 over x, and that's going to be equal to our q function, which is this x squared plus 3x minus 2, comes from here, times our integrating factor, which means we're just dividing by x, and that's integrated over x. And so if we divide through by the x, it's x plus 3 minus 2 over x. These are all standard integrals, so it's going to be x squared over 2 plus 3x minus 2 times the natural log of x plus some arbitrary constant. So now we should be able to multiply through by x, and when we do, this should get us a solution in terms of y, which what we come up with is this y is equal to x cubed over 2 plus 3x squared minus 2x natural log of x times some arbitrary constant c times x. And so this is our general solution to this linear differential equation, which again is the same as what we saw before, just rearranged a little bit.